Hi, today we're going to talk about the inverses of functions. We're going to just have a brief kind of an introduction to this. We're going to use this for pretty much every unit from now on. So we're just going to have like a short introduction to it, that way you know what's going on. It's not going to be particularly tricky. Okay, inverse. Like if you look this up in a dictionary, it says basically we're talking about the opposite. So an inverse function is kind of the opposite of your original function. So if you have, let's look at it in terms of x and y. If you have two coordinates, let's say you have 2, 3, and let's say you have another point at like 4, 7. If that's your original function, then the inverse function, we're doing the opposite. So all we're doing is we're going to switch our x and y. So the inverse of this turns into 3, 2. The inverse of this one turns into 7, 4, and that's pretty much it. You take whatever your x is and you make it a y, and whatever your y was becomes your new x. So this is the key of this entire small unit, is that you are switching x and y. Switch x and y. This should be, you could put this on a page all by itself, underline it, put exclamations, switch x and y. That's all we're doing. So, if you have, let's say you had a t-chart. Yay, t-charts. Okay, so we have x's right here, we have our y's right here, and let's say you have -3, 4, -2, 8, -1, 20, and then 1, 14. Just pretend. Okay, that's our original function. So this is our original. So then our inverse function, we're just switching our x and y. It's just that easy. We're not doing anything else. We're not really doing any math to this. We're not adding or subtracting anything. We're just switching x and y. So this is the x and y in your inverse. X, y, let's put inverse here so we know what we're talking about. So this over here turns into 4, -3. This one turns into 8, -2. This one turns into 20, -1. And this one turns into 14, 1. All we're doing is switching our x and y. Okay, let's look at this in terms of a graph. Okay, let me draw me a graph here. Okay, here's my y-axis, and here's my x-axis. So let's say we have some points. Let's say we have some points here at like -4, +2, and then let's say we have one here, and we have one here, and we have one here. Let's connect those so we have that. Okay, our original points. This one's -4 because we went to the left, up 2, so that's there. This one's -2, +1. This one is -1, +1, 2, 3, 4. And this one crosses over to the positive side, and if that's 4, then that's 5, 6, so this is at 2, 6. This is our original function. So your inverse function then, we're just going to switch our points. Let me put it in red so we can see the difference. Okay, so if we started, we had -4, 2, then our new point is going to be 2, -4. So we go 1, 2, and then down 4, 1, 2, 3, 4, so that's going to be here. Our next point, we had -2, 1, so that's going to be 1, -2, so that's here. And let's connect them because they were connected in the original. Oh, that's an ugly line. Let me reconnect that. Still kind of ugly, but okay. So then our next point we had was -1, 4, so we're going to go 4 to the right and down 1 instead. Let me rewrite these points. Okay, so this is 2, -4. This is 1, -2. This is 4, -1. And our final point was 2, 6, so we're having 6, 2 now. So that's 6, and this is 2. So this is 6, 2. So our red one is our inverse. Well, you'll notice by looking at these things, they're basically the exact same thing. They're flipped, right? But they're not flipped around to x, because if we flipped it around to x, it would look something like this instead. Or I guess that was ugly. It would be like this maybe if we flipped it around to x. So that's not what we did. We didn't flip it around to y, because then it would be something like this instead. We flipped it around this line that goes through the diagonal. Actually, let me see if I could draw this all pretty. We flipped it around this line right here, but that line right there, it's not totally pretty. Let me try this again. Let's see. Okay, now let me move it. There we go. Ta-da! Okay, so that line, this diagonal line, we know this, right? This is a line. It has equation y equals mx plus b. So y equals mx plus b. But in this case, it goes through the origin and it has a slope of 1. So this is really y equals x. So an inverse then, the inverse of a graph just takes the function and it rotates it or reflects it about the line y equals x. So inverse. Let me write that. That's a good thing to know. So inverse is reflection of a function about the line y equals x. Now remember when we had our transformations with the absolute value, we said that if it flipped over the x-axis, that was reflection about the x-axis. So in this case, this is the same thing. Reflection of it about the y equals x just means it's flipping about this line in the middle. It's flipping over this diagonal line. That acts kind of like a mirror, so we see the mirrored image. Okay, so the last thing then is if we look at this, we could look at our domain and range. So we always want to look at domain and range. We're going to look at this in every single unit too. So your domain, remember, is just all your x's, right? So this is all your possible x's. Your range is all your possible y's. Well, if an inverse is switching our x and our y, then it would make sense then that we're switching our x and our y for our domain and range too. So what that means, so if we look at this blue one, the farthest left that it goes, so we're talking domain now because domain is x's, it goes from -4 to the furthest most right point would be 2, right? So we went to a +2, that was its domain. For the range, we're looking in the up and down direction, so the lowest it goes is a +1, the highest it goes is a 6, so that's our range. Well, so your domain is all your x's, your range is all your y's, so that means that for our red one, if you look at it, your domain in the red one instead, our furthest point to the left is a 1. To the right, it goes all the way to 6. In our vertical direction, our lowest point that we have is a -4. And the highest point that we have is a +2. So notice that our domain in the first one turned into our range because we switched our x and our y. Our range of the first one turned into the domain of the inverse because again, our x becomes our y becomes our x. So that's all we're going to do with inverses, and we'll talk more about this in class.